So I'm going to do question 7, and this is where it gets more interesting, and I would encourage you doing all of the rest of this exercise. First half's been pretty straightforward, just to write down, but these go from first principles, so you need to show how we get each of these things. Question 7, the situation is clearly a Poisson distribution with that rate in there, and you need to remember what the Poisson formula is. The probability that x is equal to x is e to the minus lambda to the x over x factorial. Now, to find out what the generating function is going to be, it's the sum of t to the power of x times by the probability of x, which is e to the minus 3.5 times by 3.5 to the x over x factorial. And if you're watching this, I mean, you're going to redo it in 10 in general rather than a 3.5 do a lambda there. Now, there's a constant here. E to the minus 3.5 is just a constant. It's the same in every single term, so I'm going to drag it outside of this summation. So we're going the sum of t to the power of x, 3.5 to the power of x, all divided by x factorial. Now, just going to tidy up the top there, because they're both to the power of x, and just make that 3.5t to the power of x. Now let's think about what this summation means. So we're adding up to infinity, but starting with 0, sticking a 0 in here. So anything to the power of 0, that's going to be 1 there, isn't it? And then putting a 1 into this, we've got 3.5 t to the power of 1 over 1. Then we've got 3.5 t squared over 2 factorial. Then 3.5 t cubed over 3 factorial. And we're going on forever and ever. And we're supposed to notice that this is an expansion we recognize. This is the expansion of e to the x, where x is 3.5t. And so this is e to the 3.5t. And that means that the whole sum of this whole generating function, we've got two e's, and so we can times these two things together. Times these two things together means we can add these things here. So we've got 3.5t minus 3.5. And of course, that is the same as 3.5 lots of t take away 1. And that's what we expected it to be when we see the original formula. The original formula for Poisson is that the generating function is e to the lambda lots of t take away 1. That's exactly what we've got here. So going through that proof there, checking our understanding of infinite series expansions there, Maclaurin expansion of e to the x, that is there, going from there to there, and practice it again in number 10 with a lambda in as well.